In this lecture, I'd like to examine the HOMO-LUMO interaction between compounds. So let's look at the following example. Let's suppose we have compound 1, an alkene, reacting with compound 2, our hydrochloric acid. So this is a simple addition reaction. So in this reaction, this alkene acts as a Lewis base, this acts as a Lewis acid. So this donates a pair of electrons, this accepts a pair of electrons. So our intermediate reactants are the intermediate carbocation that has a positive charge on this carbon and has an extra H that it got from the hydrochloric acid. Now this chlorine or chloride atom now has an extra pair of non-bonding electrons, and so it develops a negative charge. In the second step of this addition reaction, we have the chloride ion donating a pair of non-bonding electrons, so this is our Lewis base and our Lewis acid. And so we form the following final product. So let's examine this picture more closely using molecular and atomic orbitals. So let's draw our molecular orbitals or atomic orbitals for this reaction. So here's our alkene, so our sigma bond and our pi bond creating the double bond. What happens is this pair of electrons, so this bond is composed of a pair of electrons, one electron in this 2p orbital and the second electron in this 2p orbital. So these two electrons attack this H atom, taking that H atom away from this chlorine atom. And we develop the following diagram. So this is our intermediate carbocation. So this bond has been formed, this covalent sigma CH bond. And now we have a positive charge on this 2p orbital because we have 3 electrons, and that means we have a positive charge on the 2p orbital. So once again, this is sp2 hybridized, and this is a planar molecule. So what happens next? Well, next we have this Lewis base. We have our chloride atom, and this non-bonding pair of electrons overlaps with this 2p orbital, forming our final product. So in the first step, this pi bond acted as a Lewis base donating this pair of electrons, and this H atom on this compound, on this hydrochloric acid, acted as a Lewis acid, donating that H, donating that empty 1s orbital. And likewise here, this is the Lewis acid because it has an empty 2p orbital, and this is the Lewis base because it has a pair of non-bonding electrons. So what exactly is a Lewis acid-base reaction? So a Lewis acid-base reaction is the interaction between a filled molecular orbital, as we saw here, and an empty molecular orbital. And this is known as a HOMO-LUMO interaction. HOMO simply meaning highest occupied molecular orbital, and LUMO meaning lowest unoccupied molecular orbital. So if we go back to the first step in this addition reaction, we see that our HOMO, the highest occupied molecular orbital, is the pi bond. So this is our Lewis base. And in this case, our lowest unoccupied molecular orbital is the anti-bonding sigma bond. Remember, the bonding sigma bond is completely filled. The anti-bonding has no electrons, and so that means it must be the lowest unoccupied molecular orbital. Likewise, in this step, this was our LUMO, lowest unoccupied molecular orbital, and this was our HOMO, the Lewis base. So let's look at the second more closely in terms of energy. So our HOMO is the Lewis base. It's the highest occupied molecular orbital that has the non-bonding pair of electrons. And this is our LUMO, lowest unoccupied molecular orbital. It's the 2p orbital, and it's a bit higher in energy than our HOMO. So they interact, they overlap to form our molecular sigma bond. and the 2 electrons go into this bonding molecular orbital, and no electrons go into the anti-bonding molecular orbital because it's higher in energy. So once again, as an overview, a Lewis acid-base reaction is simply a reaction between a filled orbital of one compound and an empty orbital of a second compound. And this is actually a HOMO-LUMO interaction.